Greetings, fellow friends of Euclid. Welcome to 2-1 Conditional Statements here in Chapter 2 of our geometry book, in which we are now studying the nature of deductive reasoning in Chapter 2. So this is the foundation of our Euclidean geometry that we are studying. We're going to learn a lot about definitions, postulates, and theorems in the days and weeks and months ahead. So let's get on with it. A conditional statement can be represented symbolically by if A then B. That's how you say that, if A then B. What is a conditional statement? If you're hopefully reading in the book pages 42 and 43 along with this video, and a conditional statement, you've probably heard a lot of conditional statements from mom and dad, like if you clean your room, then you may go to your friend's house. If you eat your vegetables, then you may have your desserts. Those are all examples of conditional statements, that if you do something, then this will happen. And so this is how we represent it symbolically, if A, then B. And we call this if clause, we also call it the hypothesis. And you're probably familiar with that word somewhat from science and from other areas. And it is similar to that. That's what we think could happen. If you do this, for instance, then that will happen. And the B part of this symbolic representation, the B part is the then clause. What is the other name for this clause? That's the conclusion. So that's if you clean your room is the hypothesis. Then you may go to your friend's house. You may go to your friend's house is the conclusion. All right. In the book, it talks about the Euler diagram. And we know that we think that we would pronounce that Euler, but his name is Euler. And you're a famous Swiss mathematician. You'll hear quite a bit about him in the years ahead in your math studies. And he made this diagram to help show how you can represent a conditional statement using this. So the conditional statement represented by this diagram is if you purchase a packet of pocket protectors, then you'll go far. So the innermost circle is the hypothesis, and the larger circle that contains the innermost circle is the conclusion. So that's how you use an Euler diagram. So that's what this particular Euler diagram demonstrates here, is this conditional statement, if you purchase a packet of pocket protectors, then you'll go far. Which reminds me of a song, and that is quite a famous song. I mean, if you ask your great-grandparents about it, they'll probably remember the song. And I'll just sing it through for you, because we should all know the pocket protector song. And so it goes like this. If you purchase a packet of pocket protectors, then you'll go far. Purchase a packet of pocket protectors, you'll be a star. Your shirt is still clean and your heart is serene, for you'll always be ready to write. If you purchase a packet of pocket protectors, then you'll go far. There you have it. Now you've heard the pocket protector song, and I'm sure you'll be singing it all night. You have a geometric night. Talk to you later.